Hello my friends, this is Ali Reza, and today I want to do a project about a 5 kilowatt system. Um, so this is the first window when you open the PVsyst, so that we do not need a preliminary design because it doesn't meet the needs for having a complete report about the photovoltaic system that we want to simulate in our software. So we skip on the project design, so that we can have a complete simulation on solar design system. So you can have the definitions here. So I click on project design. So we have 4 sections for the system that we want to define in our project. So the first one is the grid connected system is a photovoltaic system which is connected to the electricity grid from the power plant that generates electricity and transfer it to the end user, like home and like all industries that are connected to grid, and they are the 24 hours available users for that electricity generated. So that when we click on grid connected system, it means that we want to define a photovoltaic system which is directly connected to grid, and when the photovoltaic panels generate the electricity, it directly transfers that electricity to the end user by transformers and by transforming lines. And in the second one is standalone systems, like distributed generation or DG systems. It means that when you have no access to the grid, and there are no lines to transfer electricity from the main generator or power plant to the end user, and you have no access to electricity from no power plant and any generator which is connected to the grid, and it works with when you want to define a photovoltaic system to generate the electricity for a separate part of a building or an industry which is not connected into the grid, and it can be stored or it can be directly consumed, or being a DC system, or it is on the DC grid or in the preliminary design. Okay, so and in the next one you can define the pumping system and the DC grids. So today I want to doing a 5 kilowatt photovoltaic system which is connected to the grid, so that I select connected into grid. So this is the previous project I click on the new one, so that when you click on this paper with a green plus on top of it, a new project will be loaded. So as I mentioned, you can define a name for this one, so that I define it 5 kilowatt kilowatt front, and in project name I name it 5 kilowatt plot. Okay. Alright. So about the site file is that where you want to use this photovoltaic system, and it's about the place that you want to define it. Okay, well, this is the list of the countries and the regions around the world, so that you can select about the place that you want to place your site to doing your simulations, and it has the geographic data and the meteor norm, I think, and well, so let's have it for one site that I have been selected, and it was in National. Yeah, right. Okay. So you can select it from here about any country, so that we can select here. Okay, I click it. So here is the country, and here is the meteor norm dataset. So I've told in a previous video, I think, about selecting the hourly data. So as you can see here, it shows me to save the project. So I come here to save it. So it has a name and a file name, so I save it. Okay, now it shows me to no orientation is not defined, so I come here and to input parameter. So I click on the orientation, and alright. So it first that here in field type you can define the structure about the panels that you want to do the simulations about. So it can be fixed tilted plane, which is like this one here, or you can be a tracking system, or any options that you want to use. So it can be a 2-axis tracking system that you can change them here, or it can be even in east-west, or even in north to south side. Or so okay, I click on the fixed tilted plane, so it is a common to do a simulation about any photovoltaic systems. And about plane tilt. You saw in my previous video how to select it and how it affects on the transposition factor here, or any loss, or the global irradiations on the planes, which is the surface of the photovoltaic panels. It is 955 kilowatt hour per square meter. Alright, so how can I select the tilt angle for our panel onto the ground, which is settled on the ground? So first, let me open a browser system. Okay. If I want to show you how to define the tilt angle for the place that you want to do your simulations, whenever it is in Asia, or it's in America, or it's in Russia, or if you want to use your photovoltaic system in Africa. So how you can select and what should they enter on the in plane tilt, because it is not efficient to change the value from different ones so that you can have the best results here. Alright, so let's do this one. Okay, I open a browser, so I come to one of the map search, so that I can see the latitude and longitude data about the place that I want to define my photovoltaic system. So as you see here, I selected the Mashhad in for my site. So I define it here for okay. Well. Alright, and find for address. Okay, it's here. I scroll it out a little bit so you can see here. Oh yeah, this is the site that I define my photovoltaic system about the area. So I do not want this. I want these data here. Okay, the latitude, I want this one. Okay, so if I want to tell you something about latitude or longitude that you can see even in Google Map. So this is the globe. So here you say the green circles are latitude. So it has some values: 20, 40, 60, and 80. These green circles are latitude, and these red circles are longitude, and this one latitude and longitude. So that you can see here for Mashhad, the latitude is 36.29. So here Mashhad is here, and it's between 20 to 40, between these two green circles that are latitude lines, so that it's near to 40, so that exactly it's 36.29. So I just need this one, the latitude. So the 36.29. I back to PVsyst, and in plane tilt, which is the tilt angle for a photovoltaic panel. Alright, as you can see here, when I put the value more than the latitude for the place, it shows me here. Let me here. Yeah. You can see here the loss by respect to optimum is minus 0.2, so that the transposition factor is 1.15, and the global irradiance on our panel is 1954 kilowatt hour per square meter. So if I decrease it, but let me increase it first to 40, and you can see the values decrease and the losses increase. And if I make it a bigger value, you can see the tilt angle is changing and the panel is going upward. So the irradiance decreases. So if I decrease the value for tilt angle less than the latitude for this place, so that you can see it's 1958, and let me decrease it to 30, you can see it decreased. So I increase it into 36, which is the latitude for the place that we defined. Right. This the tilt panel, we take it from the map about the area that we want to use it, and right. So and it is for latitude. Right. Okay. And we want to having our photovoltaic panels faced directly into the south, because it has much more irradiance received by the panels. And right, it is 59. Let's check it. Okay, in 35 it has more value, and in 34 it has the same, and in 33 it has the same, in 32 it has the same, and in 31 it decreases. Alright, so you can select a value between 32 to 36. So we take it the 34 for this site and click it on OK. So it is OK. Alright, so we go to system that we want. So here is the system that we can define. Let's talking about these two pages here, subarrays. We have two subarrays here, and we can have two different subarrays of the panels that we want to do our simulation. So we want to define a 5 kilowatt photovoltaic system. So I want to divide it into two subarrays. So decrease it into 1 subarray, and I click it yes, so it is 1. And you can change the name here, but I leave it. Okay, you can see here we have defined the tilt in 34, and in pre-sizing help we have 2 choices to select our simulations to begin with. And you first of all enter planned power, we want to use it, and or available area, which is the square meter available for your photovoltaic systems that you want to use. So I take it into 2.5, which is half of the 5 kilowatt photovoltaic panel. So in select the PV modules, I select in available now because I want to have all of the category here, and yeah, I select the shop module, and you can select any product you want which is available for your project. And for now I select it in monocrystalline to 280. Approximate needed modules for this photovoltaic panel is 9. We need 9 modules for having a 2.5 kilowatt photovoltaic system. Okay, so next, attention here, having a tension. After you defined or you selected the photovoltaic modules, do not define the inverter. First, have a look on this blue light blue rectangle, and it shows us to choosing an inverter model. So its total power should be 9.1 kilowatt or more than this one. Okay, it is in 3-phase, so that if we want it to have a inverter in monophase, so it should be divided by 3. Okay, so okay, as this light blue rectangle tells us to select a inverter from 1.9 or upper, I come to the inverter section and select a company for the inverter. So let's select the PV, and right, it is 1.8. Okay, it is less than 1.9. Let's take a look at what it has. Okay, it is 2. It is exactly 2 kilowatt, and there is no error with this inverter selected by the PV module, and everything is okay with your system. Okay, and the next step you should take care is here, number of modules and number of strings. Here, modules in series should be 9. Okay, and the number of strings is one string with 9 modules in it, or one string with 9 modules having inside itself. Alright. With the panels. Alright. Alright. So let's begin our simulations. So I can it to be a quick one so that you can see the details. Okay, on detailed losses we have different parts to be completed, but I just want to define the soiling loss, which is 3 in default. Okay, and in aging you can define a degradation in here, and you can put it to be in your project, in which it's in 10. You can decrease it into another one. So it has a defined degradation factor, and right, okay, everything is okay here. So we have just defined a soiling loss. Okay, and in horizon, and in horizon we can define it with any devices that we have used, or something like soil metrics on eyes. You can select the file that you have in your system, or you can import it from any other websites. Okay, right. Okay, so come to near shading. This is the new part for PVsyst. Okay, it's the near shading that you can define the near shading, and the horizon is for far shadings, like the mountains or something like that, which is the for the geological and about something like that. And in near shadings is about the trees, the buildings, and anything that can have a shadow on our systems. So this is the window for near shading, and here you can see the active area for site is 15, and the 32 for the system is 15, and the tilt angle is 34. So I come here to this construction perspective, this one here, and select it. Okay, to begin structure the system and settle it. So this is the interface for the system define, and here we have different options and drop down menus, and some options available here for quick access. And the pan, we have the pan here, which is necessary for moving around. Okay, so I click on the arrow to having to be able to having control on the screen. So I want to define, as we saw in system here in the main window for PVsyst. In system part we have one string with 9 modules in it. So we have to define this system here to be defined for near shading. Okay, so let's begin here. In create drop down menu, I select the PV table as sheds. Okay, this is the new window to showing right here. Okay, as a default I scroll it out and scroll it in so that you can see it in a better. Okay, as a default we have 3 modules so that we can define it here. Here let me we have oh, that's too side. Okay, a thinner one. Okay, we have 2 options here. One of them is basic and the another one is by modules. Okay, this here, this one here is for basic. Okay, this one here is for basic. In basic, what we have, okay, let's begin from the first. Okay, we have description, you can change it here, but I leave it as the default. And the layout of the module. Okay, one of them here. The number of sheds, we have 3 sheds as our modules. Okay, and this is the this series. Okay, this series that defined in system. So we have 1 series, and I decrease the 3 into 1 so that it has it makes a 1 module. So I scroll it out so that you can 1 module here. And if we had a more kilowatt, for example, we have a, for example, if we have a 10 kilowatt or 5 megawatt, it has a more than 2 or more than 5 strings, or maybe like that, and we have to define more number of sheds, which is the string numbers, and we can have them here. Okay, so here we have 1. I'm sorry, we want to define a 5 kilowatt, but I have defined 2.5 kilowatt. Alright. Okay. Let's begin. Let's continue into this one, and I'll show you how to define 2 subarrays. for the photovoltaic systems. Okay, because I want this video to be a quick one. So here I have one series. So I select 1 for number of sheds, and for shed tilt, which is the tilt angle for that we have defined in orientation part for our system, which is 34, and slope is 0 and baseline is 0, and the pitch is the distance between two panels. If I define two modules here, the pitch is 5, which is the distance from one of the modules to the another one. If I increase the pitch into 8, so that you can see more more space between them, and if I put it into 10 and click enter, their distance become more. And if I put it into 2, the 2 value for pitch, you can see these two modules are so near together, and we have so much shade or so much shadow on the behind one. And if we have if we have 3 modules, the shadow will affect on the solar generation of solar generation of the panels effect. So I'll leave it into so here we have one string, and it doesn't matter that what value you define it for here. Okay, and alright, everything is okay for here. Okay, and these are the values for the original panel. Okay, so the total area and required area for settling this module is 14.7 square meter. And alright, we are in basic, so let's move into by modules. Okay, so let me change this one and take another color. So yeah, by modules. Okay, what we have here, modules by rectangle. Okay, here. Okay, we have this type of module, and the module width, and the module height, and the orientation. What orientation you want to define for your photovoltaic panel. Okay, if I take the landscape, it needs more area to being placed on a surface that I want to settle my photovoltaic panels in my project. So I take the portrait one to have a less area for my photovoltaic system. So the number of X modules, if I have a vector X vector here, let me draw it. Okay, take this green arrow be X, and this blue arrow be Y. Alright, so as I change the X modules number for X modules, the default has 4. Okay, it increase in align with the green arrow, which is the X. Okay, I can decrease or increase the number of modules across the X, and also I can increase the number of modules across with the blue line, which is the Y, here. Okay, so we can see when I have one module and one Y, we have two positions from X and Y. Okay, so when I increase it, it has 1 in Y modules. So if I want my module to be in double steps, so I increase the number of modules into the double ones by increasing it across the blue arrow. Okay, so in our simulation we had 9 modules in series in the system part, so I have to define 9 modules here. Scroll it out, and you can see here 9 and 1 in Y. So next I have to click on adjust the modules to having them all together in a module. Okay, this is our module. Okay, alright, and it has the width, length, and number of modules. It has 9 modules, and the rectangle area is 15.2, and the total area you can see here. Okay, and also you can change the color here, which is the graphical work. You can change them here into any other colors that you want to be shown here, but I'll leave it into the default, and you can select the shadow color when you simulate your project here. Okay, so I click it on close because I defined my photovoltaic system. Okay, it has here. We have it in our perspective here in the main menu for Near Shadings. Alright, so as you can see here, it's not complete, right? We have defined them here. We have defined our modules here. We had 9 modules, but there is no modules here. It's empty. So next we have to define it again. Okay, it's here. Okay, let me show you here. Oh, here, this one. I click on this one to define my modules for my system. So let me click it. Okay, this is the new window, and I have here in the addition I have number of strings, okay, in width or in height, which is the same as with the X arrow and Y arrow in the PV table as shared that we have defined in the previous window, right? Okay, in width we had 9 and enter, and in height we had 1 enter. Okay, so we have our modules here, 1 string and 9 modules. Okay, everything is okay. So I click on close. So yeah, we have our photovoltaic system. Okay, so you can define your building here by clicking on create something. Let me show you. Let's oh yeah, let me. Okay, if I want to define a object to study the shading effect on electricity generation by our photovoltaic system, I come to create, and the elementary shading object. Or if I want to define a building, I click on building a component object. Okay, so let's begin with the elementary objects. Okay, the new window is opened, and here in shape type I click it, and I want to define a tree. I search for, you can define any other things as here, house, like, oh yeah, it's a tree, and it's here. This is a tree. You can change the values for this one, and the trunk height I can let it to be 1. Okay, you can see it's a too tiny. Okay, so I click on 2, or the medium diameter. It's let's begin it being at 5. It's wider, and let it to be 2. It's a thinner. Okay, so it's on 32.5. 0.5. Okay, is everything okay? And okay, you can change them here, and it's like any object that you want to define, like houses or anything others, that, or walls, fences, or anything that you want to define. You can change it here, and its height, its width, or anything like that. And this one is the color, and you can select the color of your tree. Okay, I leave it on the default and close it. Alright, as you can see here, my tree is exactly in front of my panels, and it's inside my panels. So I want to move it. Okay, we have 2 options here. I show you how to do that. Okay, to move anything in the surface, first of all you have to click that object. So when the object is red, it means that object is available to changes that you want to define for that object. And if I want to change the number of modules here, I click on the modules, and it becomes red, which means it is activated and it's ready to define my changes into that way. Okay, so now I want to move the tree, or move the modules. Okay, so I move the tree here. I click on tree, it becomes red, and I click on modify here, the middle one, 4 arrows. Okay, well, okay, when the tree is active, okay, I click on move, modify. Okay, we have 2 choices to move our tree. One is to use these 3 arrows here. When I click it and drag it, I can move the tree from north to south. Or when I use the red arrow, I can move my tree from west into east. Okay, and the second, and even you can move your tree in Z, which is the blue arrow. Okay, but when you decrease it, it shows you that the Z value is decreasing into -1, -2, and yeah, even if you lost your geometry, you can use this one, and this is the second way you can change the position of your object, which is activated. Okay, so let me put it into 5 meter to west. 5, enter, and it moves. Okay, if you lost your Z, let me be it here, and I couldn't exactly put my tree on Z to be 0. I come here and leave it to 0, and everything is okay, and you can see the Z is 0. Okay, everything is okay, and I click on the surface to disable the object. Okay, so this is our perspective in Near Shadings. You can define anything here to study your shadings and to be a more realistic project. Okay, another thing that I want to show you to use it to take a look more realistic is this render, and when I click it, you can see the colors that we have defined for our objects here, as the tree is green, and you can do changes here as you click on objects, and you can move them around here, or doing some distances between any objects. So let me put it here so that you can see a more realistic solar effect. Okay, so I want to take a quick simulation on a day, so I come here to view and into shadows animation over 1 day. I click it, and the date that I want to having my quick simulation and a visual one is here, and I can select any of the dates, and the step duration is 15 minutes. You can increase it or you can decrease it here. Okay, and I click on run animation to have my animation. Okay, as you can see here, the effect of the shadow on the panels was a grey. Okay, and you can see here the shading loss on clear day, beamliner loss is 14.7% over 1 day, and it's from 10 to from 9 to 30, from 9 AM to 1 PM. Okay, we have a loss here, a loss of electricity generation by our photovoltaic panels, and when you see the yellow spots on the photovoltaic panel, it means that we have shadows on our panels. So let me play it again so that you can see the shadows are here. And this shadow is made by the sun when it moves from east to the west, and this is the sun that moves around from east to west. Yeah, okay, let me show you again from east to west, and when it moves, the shadow falls on the photovoltaic panel and will affect our generation, and we have a fewer electricity generated by our panels in that time of day. Okay everyone, this is my video about a 2.5 kilowatt photovoltaic system, and I hope it will help you to do your projects and have a better understanding on photovoltaic systems. And I'm sorry about uploading it so late. Alright, and have a good day.